Hello everyone, myself Sachin Gaware from RBNB College, Shrampur. In today's lecture, we start a chapter linear programming from mathematics paper first of 12th science. Now, for this linear programming, we have to study first the linear equation and linear inequalities. Now, we know that ax plus by plus c equals to 0, where these a, b and c are the real numbers and a and b are not 0 simultaneously, or we say that a and b are not 0 at a time. Then these ax plus by plus c equals to 0 is called as a linear equation. Also, this linear equation represents a line. This linear equation represents a line. Now, if we draw this line in a plane, suppose this is the coordinate axis. This is x-axis and y-axis. And suppose here this is the line ax plus by plus c equals to 0. This is the line ax plus by plus c equals to 0. This is the straight line. Now, clearly this linear equation or this straight line divide given plane into two parts. One part is this one and the second part is this one. That is, we can say that any line, any straight line divides the given plane into two parts or into a partition. Partition means two disjoint parts. So now we have to study the parts made by this line of the plane. And now in this part, these two parts are represented by the linear inequalities. Now, what is the linear inequalities? Now, the equation of the type ax plus by is less than or equals to c, or ax plus by is greater than or equals to c. These two types of inequations or inequalities are called as linear inequality. Again, this linear inequality holds the condition that a and b are not 0 simultaneously. A and b are not 0 simultaneously. So, now in this case, if we consider the graph for the line ax plus by plus c equals to 0, the part above the line away from the origin, that is this part, this is the part for the inequality ax plus by is greater than or equals to 0. And this part which is the below the line, this is the part for ax plus by is less than or equals to c. Now, we study here in linear programming, we study these types of linear inequalities. These types of the linear inequalities. Before studying the graph and the structure or the properties of these linear inequalities, we have to study first one more important definition, which is called as an convex set, which is the convex set. Now, the convex set means it is the collection of all points of a plane. Convex set is a collection of all points of a plane such that if we join any 2 points, say here a and b by a line segment, and if that line segment wholly lies in that collection or that figure, then that set of a point is called as a convex set. Is called as a convex set. For example, here this first figure is a convex set. Similarly, if you draw a triangle and we join any 2 points from this triangle, say by a line segment AB, then this line segment AB is wholly lies in this triangle, so it is also convex set. But if we consider a set of points like this, and here if we join the 2 points A and B here, this is the point B and this A, then this part of this line segment AB, this part of line segment AB is outside this set of the points of the plane, and therefore this is not a convex set. This is not a convex set. We can take one more example for this convex collection of points which is not a convex set. Suppose this is the points. If we consider these points, that is the ring shape. Now in this condition, if we take the point A here and a point B here, again the some part of this line segment, does not lies in that set, and so this is not a convex set. So that is the definition of convex set is, it is the collection of the points in a set such that if we join any 2 points by a line segment, if that line segment wholly lies in that set, then that collection of points in a plane are called as convex set. And remember, one characteristic or property of convex set, that is the any function defined on that convex set, any function defined on convex set has an optimum value. Optimum means either minimum or maximum value of that function on boundary or corners of that convex set. And second thing is, this convex set may be bounded, may be unbounded. If we consider a parabola, suppose parabola, and if we consider this is the set. Now this set or the points lying in the parabola, this is the unbounded convex set. This is the unbounded convex set. Okay, now we have to study the different conditions now of the inequalities or the different inequalities and their graphs. Now the first one is x is less than or equals to h. X is less than or equals to h. Now if we try to draw for this x equals to h, before to study the region of x is less than or equals to h, we draw a line considering this inequality as equality, that is we consider the line x equals to h. Now suppose this is the line x equals to h. This is the line x equals to h. Now the region for which x is less than or equals to h is a left side region. This is the region for x is less than or equals to h. This is the region for x is less than or equals to h. Again here this region is unbounded region because this can be extended up to infinity. So it is the unbounded region. Now next type is number 2, x is greater than or equals to h. Now again if we draw a line x equals to h, x equals to h. Now suppose this is the line x equals to h. Then the region for x is greater than or equals to h is the right side of that line. So this is the region which shows for x is greater than or equals to h. This is the region for x is greater than or equals to h. Similarly, for the lines parallel to x-axis, that is the third condition. Suppose we consider y is less than or equals to k. Y is less than or equals to k. Now again, if we draw a line y equals to k, suppose this is the line y equals to k, then the region for y is less than or equals to k is the region below that line. That is the region below the line y equals to k. So this is the region for which y is less than or equals to k. Y is less than or equals to k. Now similarly for the fourth condition, that is y is greater than or equals to k. Y is greater than or equals to k. Again, if we draw a line y equals to k, if we draw a line y equals to k, then the region which is represented by y is greater than or equals to k, fourth condition, then this region is the region above that line, that is above the line y equals to k, above the line y equals to k. So this is the region for y is greater than or equals to k, and this is the line y equals to k, y equals to k. That is when y is greater than or equals to k, we consider a region above the line. If y is less than or equals to k, we consider a region below the line, a region below the line. Similarly, if we consider x is greater than or equals to h, x is greater than or equals to h, we consider a region right side to the line, and for x is less than or equals to h, we consider a region to the left side of the line x equals to h. Now we consider the combined, that is the linear inequalities. We consider now the linear inequalities. Now the fifth condition, which is for linear inequalities. Now here, if we consider a line passing through origin, that is ax plus by, suppose we consider here it is greater than or equals to 0. Since here a constant term, that is a term free from x and y, is absent, so this equation ax plus by equals to 0 passes through the origin. So now again, if we try to draw this line on a plane, this line is of the type like this. This is the line ax plus by equals to 0. Now here we have to show that the region for ax plus by is greater than or equals to 0. So we consider a region above the line. We consider the region above the line. That is, this is the region for ax plus by is greater than or equals to 0. Now if we consider the next condition, that is a condition for ax plus by is less than or equals to 0. Now again we draw a line ax plus by equals to 0. We draw a line ax plus by equals to 0. Now for the region ax plus by is less than or equals to 0, we consider a region below the line. A region below that line. So this is the region for ax plus by is less than or equals to 0. These are the lines. Here we consider the lines which are passes through the origin. Now the next condition is for the line or a general line or a line which not passes through the origin. So the next condition is ax plus by, it is greater than or equals to c. Ax plus by greater than or equals to c. Now again if we plot or draw a graph for the line ax plus by plus c, then that line is of the type like this. Suppose this is the line. This is the line ax plus by equals to c. Ax plus by equals to c. Now we have to consider the inequality or a region for ax plus by is greater than or equals to 0. Since it is greater than or equals to 0, again we consider a region above the line. A region above the line. So this is the region for inequality or inequation ax plus by is greater than or equals to 0. Now the last type, that is for the line or inequation ax plus by less than or equals to c. Ax plus by less than or equals to c. So again if we draw this line ax plus by equals to c, a line ax plus by equals to c. Now we have to show the region for ax plus by is less than or equals to c. Since it is less than, again we consider a region below the line. A region below the line. So this is an region for ax plus by is less than or equals to c. So again see here, the region for ax plus by is less than or equals to c is the region below the line ax plus by equals to c. For the region ax plus by is greater than or equals to c, we consider a region above the line ax plus by equals to c. Similarly, for the lines passing through the origin, that is ax plus by equals to 0, the region for ax plus by is less than or equals to 0 is again in below the line of ax plus by equals to 0. And for ax plus by is greater than or equals to 0, we consider an region. We consider an region above the line ax plus by equals to 0. These are the all cases, all types of inequalities for which we can draw or we can shade the regions for the given inequalities. Now we solve the exercise 7.1 in which we have to show the regions for the given inequalities. Now in this exercise 7.1, the first question is 2x plus 3 is greater than or equals to 0. Now here we have to show that the region for this inequation 2x plus 3 is greater than or equals to 0. Now to draw the graph for this one, first consider the equation. Convert this inequality into equality. So this line becomes 2x plus 3 equals to 0. From this we can write 2x equals to minus 3, that is x equals to minus 3 by 2, or we can write it as minus 1.5. Minus 3 by 2 is nothing but minus 1.5. Now to represent the given equality, draw a plane, the x-axis and y-axis, and suppose here we take 1, 2, minus 1 and minus 2, the points on the x-axis. Obviously the center is the origin. So now take a point x equals to minus 1.5. Now the minus 1.5 is in between minus 1 to minus 2. So draw a line which passes through this point minus 1.5. So this is the line which passes through the point minus 1.5. So this is the equation for the line 2x plus 3 equals to 0. This is the equation. This is the line for the equation 2x plus 3 equals to 0. Now here the inequality is of the type greater than or equals to, and we already say that whenever there is the inequality of the type greater than or equals to, we consider a region right side to that line. We consider a region right side to that line. So the region for the inequality 2x plus 3 is greater than or equals to 0 is this portion. This is the portion. This is the region for 2x plus 3 is greater than or equals to 0. Now here we consider if we have given the inequality of the type, suppose it is the less than or equals to. Here we consider the inequality, that is 2x plus 3y is less than or equals to 0. In that case, this whole thing, that is up to finding the equation of line, is same. That is, again we draw a line 2x plus 3 equals to 0. That is, the line passes through the point x equals to minus 1.5. But now here the inequality is of the less than or equals to type. In that case we consider the region which is the left side of that line, because the inequality is less than or equals to types. So in this case, whenever the inequality is of the type less than or equals to, in that case we consider the region which is the left side of that line. So this is the region. This is the region for 2x plus 3 is less than or equals to 0. This is the region for 2x plus 3 is less than or equals to 0. Now we consider one more example for this, that is 5y plus 3. 5y plus 3 is less than or equals to 0. Now again convert this inequation or inequality into equality. So here this can be written as 5y plus 3 equals to 0. So from this we can write 5y equals to minus 3. That is y equals to minus 3 upon 5. Now this minus 3 upon 5, if we divide this one, this becomes minus 0.6. Minus 0.6. Now we draw a plane. Now we draw a plane showing x and y axis. Again, here suppose this is the point x, y equals to 1, y equals to 2, y equals to 3. Similarly here, it is y equals to minus 1, y equals to minus 2, and y equals to minus 3. Now, y equals to 0.6. Y equals to 0.6 this is the point, y equals to 0.6. Now, draw a line, y equals to minus 0.6. Suppose this is the line. This is the line, y equals to 0.6, and that is 5y. Y equals to 0.6, that is 5y plus 3 equals to 0. This is the line. Now we have to consider a region of the type less than or equals to, because here the inequality is given 5y plus 3 is less than or equals to 0. So we know that again the inequality, if the inequality is of the type less than or equals to 0, we consider an region below the line. We consider an region below the line. So this is the region. So this is the region for the inequality 5y plus 3 is less than or equals to 0. Now again we consider the another condition for this equation. If here it is of the type greater than or equals to. If the inequality of the type greater than or equals to, that is this inequality is given to be 5y plus 3 is greater than or equals to 0. Again we convert this into line and we find the point y equals to minus 0.6 and we draw a line parallel to x-axis. That is 5y plus 3 equals to 0. But if we consider the inequality of the type greater than or equals to 0, then we consider a region. We consider a region above the line. We consider a region above the line. So the above the line, the region above the line is represented by 5y plus 3 is greater than or equals to 0. 5y plus 3 is greater than or equals to 0. Now for the lines, now next consider the line. Suppose x plus 2y is less than or equals to 6. Suppose now we have to draw the graph for this inequation. Now to draw the graph for this inequation, consider it is then a line. First we plot the line. So for plotting the line, we consider the equation x plus 2y equals to 6. X plus 2y equals to 6. Now to draw this line, we have to find the 2 points from this equation. Now to find the 2 points for this equation, there are different ways. There are different ways for that. Out of that, we consider one way. Here we make a table which shows the equation of line, that is x plus 2y equals to 6. Now we find the 2 points. We find the 2 points by putting the value of x equals to 0 and the another, that is putting value of y equals to 0. Now if we put x equals to 0 in this equation, we get 2y equals to 6, and which gives y equals to 3. So we get the point 0, 3. Again see, if we put x equals to 0 here, we get 2y equals to 6, which gives y equals to 3. So we get the first point 0, 3. Now similarly, in this equation, if we put y equals to 0, we get directly x equals to 6. So the given point we get, that is the 6, 0. We get the next point, that is 6, 0. Now connect these 2 points on a graph. So now to draw this graph, suppose this is the coordinate system, this is the x, this is the y axis. Now suppose here it is 1, 2, 3, 4, 5 and 6 x-axis, and y-axis for 1, 2, 3, 4, 5, and suppose this is the 6. Now the first point is 0, 3. Now this is the point 0, 3. This is the point 0, 3, which lies on y-axis. Similarly, the point 6, 0, which lies on x-axis, this is the point 6, 0. Now connect these 2 points. Connect these 2 points. So we get, this is the graph for the line. If we connect these 2 points, this is the graph for the line x plus 2y equals to 6. X plus 2y equals to 6. This is the line. Now check the condition or inequality sign. Now here the inequality is of the type less than or equals to. And we know that whenever the inequality or inequation is of the type less than or equals to, we consider a region below that line. So this is the region. This is the region for the inequation x plus 2y is less than or equals to 6. X plus 2y is less than or equals to 6. Now in next lecture, we find a region combined by 2 inequalities. So that region is called as a feasible region. So for this lecture we stop here. Thank you.